Macam mana nak dengar suara saya tak cat lagi. On pun tak lagi. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah sihat. Semua sihat eh? Ni nak test petang ni. Sampai sini. Sampling for proportion. Boleh nampak tak? Boleh eh? Sampling for proportion. Actually, saya dah bagi dah. I already give you the link about the sampling for proportion, sample proportion. In English and in Bahasa. So I hope you already look at that videos, because this is quite confusing, and I hope most of you, or maybe all of you, already get the books. Semua dah dapat buku dah? Okay. So when you already have the book, so it's easy for us to Afika belum lagi. Dia cakap bila Afika? Seller cancel saya punya order itu. Dia cakap apa? Cancel order. Cancel order lah pola. Dia tercancel. Mangai. Boleh pula dia tercancel saya ada contact number untuk penerbit tu, yang kalau ada student yang tercancel ke boleh call Encik ni lah, Encik Fadli. So anyone who has already cancel the order by the seller, so maybe you can PM me to get the contact number for this Encik Fadli. Okay, Afika. So maybe you dah order a few days ago, to cancel. So you have a new order. Okay, so kena tunggu lagi lah, mungkin dia buat second batch kot. So 500 copies already sent to the student for the first batch. So hopefully for the they not take too long to print the second batch, so that you can have the book. Okay, so most of you already get the book, so it's easy for us to discuss about the topic. And don't forget to scan the QR code for your attendance. Okay, so most of you already inside this Google Meet. So maybe we now sampling for proportion. I don't know which page in your books. I just got the old version, so maybe you can share. Sampling for sample proportion. Which page? 46. 46. Aisha said 46. So maybe already get the book. So maybe you can look at 46, sampling distribution for the proportion. Okay, sampling distribution for the proportion. So maybe I assume you already look at the videos that I share, and maybe you can read the introduction about the proportion now, the sample proportion, and about the population proportion. Uh, yeah, another one. Chimchong. Chimchong baru masuk. Okay. So sampling for proportion. So maybe I can use this capital, this P. This is a sample proportion. And pi is the population proportion. Okay. I repeat again. Sampling for proportions. So P is a sample proportion and pi is a population proportion. So this is the formula for P. This is equal to X over N. And we have the same formula for pi. Pi is equal to capital X over capital N. So this is X. What is X? X is actually represent if pi and P we consider as a success, the sample proportion for success. So X will be number of success. Okay. And the small n represent the size of the sample. Okay, the size of the sample. This is also represent the same thing but refer to the different group, the population. So capital X will represent the number of success in this population. So capital N is the size of the population. Okay, so that is the meaning of that is the formula for P and pi, sample proportion and population proportion. Okay, if you look at this number of success, if you read in your books, this is actually came from binomial distribution. Okay, this is X came from binomial distribution. If you remember what is the possible value of X in binomial distribution, that is start with 0, 1, 2, sorry, 2, 3, until the last one is N. Okay, this is X in binomial distribution represent number of success. Okay, but when we the original this is from binomial. Okay, so when we divide with n, so we will have n over n, this is over n, this is over n, this is over n, until this one is over n. So the value of p, if you look at this value, 0 over n, 1 over n, 2 over n, 3 over n, until n over n, the value of p will be between 0 and 1. Okay. So if you look at the your books, central limit theorem said the distribution for p is follow normal distribution with mean pi and the variance pi 1 minus pi over n. Okay, that this is the distribution for proportion, sample proportion. But unfortunately, the original values of x is came from binomial distribution, which is this is a discrete. So this is only the single value 0, 1, 2, 3 until n. That is a discrete. But when we divide with n, is become p will become a continuous. Okay, this is a continuous because follow normal distribution. That's why if you look at in your books, I don't know which page, maybe 46, 47, 48. Maybe you can look at 48, page 48. There is one subtopic called continuity correction factor. Ada tak? Betul ke? Muka surat 48. Ada? Oh, 47. Sorry. 47. 47. Continuity correction factor. How many formula? How many formula continuity correction factor? 5. 5. Can you remember all that 5? We assume maybe in test maybe you can refer, maybe you can refer, but in final maybe our final will be face to face. You need, so you cannot refer to that books, you cannot refer to that formula, and it's not given in the list of formulas, so you need to remember that 5 formula. Can you remember that 5 formula? Boleh tak? Boleh cuba hafal. Okay. Tapi jangan pula tulis kat mana-mana, buat nota, buat koyol pula nanti kalau face to face exam. Okay, so continuity correction factor, why we need to do continuity correction factor, CCF? Because the original distribution for x is discrete, and but the distribution for proportion is a continuous, follow normal distribution. Okay, so continuity correction factor. So if anybody cannot remember that formula, I will explain to you how to get that formula. Okay, so you need to listen carefully. If you don't understand, you can ask me. Okay, continuity correction factor. Okay, this is, remember, you need to remember, this is the first step. Okay, before we can transform P to Z. Why we need to transform P to Z? Because P follow normal distribution. Okay, so before, this is very important, before we can transform P to Z, we need to do CCF first. Okay, this is the first step. The first step, we need to do CCF first, continuity correction factor first, before we can transform P to Z. So what we need to do in CCF, either we plus 1 over 2n, or we minus 1 over 2n. Okay, what is n? N is a size of the sample. N is the size of the sample. Okay, either we plus 1 over 2n or minus 1 over 2n. Okay. Okay, I will explain to you. Okay, so if you remember, let's say this is, let's say this is the line, the line number for x in binomial distribution. So this is 1, this is 2, this is 3. So let's say this is represent y-axis, represent the frequency. Okay, so if we draw what we call as a bar chart, this is the bar chart for discrete. Okay, it's not touch each other. Okay, this is discrete. Okay, so how can this bar chart become touch each other? So we can draw the histogram. This is the histogram. This is 1, this is 2, this is 3. So the histogram will become like this. Let's say like this. Okay. So we open the boundary half to left and to the right. So now from discrete become histogram. So this is the reason why we need to plus 1 over 2n or minus 1 over 2n, because the distance between 1 to 2, 2 to 3, what is the distance between this value? The distance. What is the distance? 1. Okay, 1. The distance between 1 to 2, 2 to 3, the distance is 1. So from discrete to histogram, okay, from bar chart to histogram, we open the boundary half to the left and to the right. Okay, so that the width of the chart will be equal to each value. Okay, so this is half. So we move half, 1 over 2, we move to the right half. For these two value, we move to the left half and we move to the right half. For these 3, we move the boundary to the left half and we move to the right half. Okay, that is y half here. So y n. So if this value from binomial distribution 1 to 3, we divide with n. We divide with n because the formula for p, okay, the formula of for p is each value of x we divide with n. Okay, setiap nilai x itu kita bahagikan dengan n. Okay, now so this is over n, this is over n, this is over n. So what is the distance now between 1 over n to 2 over n? The distance between 2 over n to 3 over n. What is the distance? 1 over n. Okay, good. Okay, good. Okay, so now the distance is 1 over 2n. 1 over n. So now we need to divide equally to the left and to the right. So that's why this become 1 over 2n, 1 over 2n. This is 1 over 2n, this is 1 over 2n, this is 1 over 2n, this is 1 over 2n. Okay, so that's how we get 1 over 2n. Okay, so that is how we transform, what we need to do about the continuity correction factor. Okay, 1 over 2n. Okay, now I will show you to make a decision. Either we need to plus 1 over 2n or minus 1 over 2n. Okay, so since we know the value of p, the value of p is between 0 and 1. So let's say we want to find the probability for this one, 0.3. Okay, we want to find the probability for the sample proportion is at least 0.3. Okay, remember the first step, we need to do a CCF. Okay, how to make a decision? Okay, by drawing the line number for this P. Okay, let's say we draw the line number for this P. Let's say this is 0.3. Okay, now this is 0.3, this is 0.3. Okay, now look at this value. Look at this equality symbol. Look at this equality symbol. Okay, greater than or equal. So this is equal. Include 0.3. So when we learn about the line number, when the value is include, we bold or we circle. When include the value 0.3, we bold it. Okay, good. Okay, we have a same teacher. Okay, so we bold the value. Okay, we bold the value. Okay, now the arrow is greater than, this is greater than or equal, greater than or equal. So that's mean the value is to the right. Okay, any value to the right. Okay, so now in this case you have two options. Okay, you have two options. So the probability, the proportion is at least greater than 0.3. Either you want to plus 1 over 2n or you need to minus 1 over 2n. You have two options. Okay, you have two options. Okay, so this is 1 over 2n. Okay, okay, now look at here, Najib. Be careful, be careful. I will show you. Listen carefully. Okay, now you have two options. Either you move a little bit to the right or you need to move a little bit to the left. Okay, you have two options. You need to move a little bit to the left or to the right. Okay, now imagine you have a rubber band. Do you know rubber band? Getah gelang. You know rubber band? Okay, now imagine you have a rubber band. From this value, look at the cursor of my pen. Okay, from this value, the ball value, imagine you have a rubber band and you pull rubber band, you pull to the right because the arrow is to the right. Okay, so now you have a rubber band from this 0.3 to this one. Okay, that is, imagine that is your rubber band. Okay, now you have two options. You have two options. Let's say you make a decision. You make a decision just like Najib said. Okay, let's say you imagine you make a decision to move a little bit to the right. A little bit to the right. Okay, now little bit to the right. So your rubber band will move a little bit to the right. We'll start from here until to the right. Okay, Imagine like this. So now this is your rubber band. Okay, this is your rubber band. Is it rubber band? That is the or BAN. That is band. Is it rubber band? That's rubber lah. Rubber. Oh, sorry. Rubber band. Thank you, Afika. Okay, rubber band. Okay. So let's say that is your rubber band. Okay, this is if you make a decision to move a little bit to the right. Okay, now you need to go back to this equality symbol. This equality symbol said is include 0.3. Now look at your rubber band. Is it include 0.3? No. Okay. Since when you move a little bit to the right, and in this case it's not include 0.3, but you should, from the question, it should include 0.3. That means your decision to move a little bit to the right is the wrong decision. Okay, so now, okay, so now remember what I said, you have two options. So now let's say you want to, in this case, it's actually you need to move a little bit to the left. So when you draw your rubber band, imagine your rubber band. Now this is your rubber band, and now you check again. Oh, this is include 0.3, and your rubber band is include 0.3. That in that case, your decision to move a little bit to the left is the right decision. So when you move a little bit to the left, in this case, you need to minus 1/2n. Is it clear? Okay, now we try again. We try another example. Okay, now let's say let's say this is the first example, this is the second example. Okay, now let's say we want to find the probability for the sample proportion less than 0.5. Okay, now do the CCF. Okay, don't look at the formula. Don't look at the formula. Okay, don't look at the formula. Okay, use your own decision making. Proportion, this is 0.5. Okay, now in this case, mana hilang pula. Okay, in this case, again we draw. Again we draw the line. So this is 0.5. So now this is not include 0.5. So we just circle it. And the arrow, this is less than, so the arrow will be to the left. So imagine now you have a rubber band here. Imagine you have a rubber band here. Okay, now you have a two option also. Either you can move a little bit to the left, or you can move a little bit to the right. So in this case, you need to move a little bit to the left or to the right. Right, left, right, left, right, left. Okay, now we discuss. Okay, we discuss. Okay, now, okay, it's okay, okay, now, okay, let's say you can for the first time you can choose either you want to move a little bit to the left or to the right, doesn't matter. Okay, but the next you need to ask yourself. Okay, let's say I decide to move a little bit to the left, to the right. Okay, what happened? Okay, now what happened? I will pull the rubber band from here to the left. Okay, this is the decision if you make a decision to move a little bit to the right. Okay, now ask yourself, look at back to the question. This is less than 0.5. Now look at your rubber band. Is it your rubber band include 0.5 here? No, what do you mean no? I ask you, is it your rubber band include 0.5? If this is your option, you move a little bit to the right. Is it include, right? 0.5. Include 0.5. Your rubber band include 0.5. But the question is not include. The question is not include 0.5. Therefore, your decision to move a little bit to the right, is it right or wrong? It's a wrong decision, right? Okay, because it's include 0.5, but the question said not include. Therefore, your decision to move a little bit to the right is a wrong decision. Okay, so in this case, you should move a little bit to the left. If you move a little bit to the left, your rubber band will start from here to the left. So it's not include 0.5. So in this case, this should be minus 1 over 2n, because your decision, the right decision is move a little bit to the left. Okay, is it clear? Second. Okay. Okay, we try another one. The third one. I don't want you to memorize the formula. Okay, I want you to understand why why you need to add 1 over 2n, why you need to minus 1 over 2n. Okay, because there is a reason. Okay, I don't want you just become a just like robot to memorize everything. Okay, unless I ask you to remember, to memorize. Okay, so let's say we want to find the probability, the sample proportion is less than 0.3 and 0.6. Okay, now do the CCF. Okay, do it now. 0.3, we need to plus or minus 1 over 2n. 0.6, we need to add or minus 1 over 2n. You are the one who need to communicate with yourself. Okay, either your decision to move a little bit to the right, is it the right decision? Or you want to move a little bit to the left, is it the right decision? You need to ask yourself. That's how we make ourselves understand. Okay, try. Imagine this is 0.3, this is 0.6. In this case, it's not include 0.3, it's not include 0.6, so we just circle it. Okay, so in this case, this is your rubber band, this is your rubber band. Okay, now for the bound, for value 0.3, we need to move a little bit to the right, or we need to move a little bit to the left. Yes, very good, very good. So in this case, we need to move a little bit to the right. Very good. Okay, now for 0.6. So since we move a little bit to the right, so this should be plus. Okay, look at 0.6. We need to move a little bit to the right or to the left. Yes, very good, very good, very good. So we need to move it to the left. Okay. Okay, so since we move a little bit to the left, this is minus. Okay, is it clear? Okay, so you don't have to memorize all that 5 formula. Okay, any question? No, any question? Anyone? Any question? Okay, if there is no question, maybe we can try to solve one question. Is there a method to memorize the symbol? Okay, you don't have to method to memorize the symbol, just from your understanding. Okay, okay, Najib, look at here. Okay, Najib, look at here. Okay, for this value, it said it's not include 0.3, right? Najib, it's not include 0.3. It's not include 0.3, but the value, why just now second question include 0.5? What do you mean include 0.5? This one, this one, go after CCF. Okay, okay, look at here. Okay, look at it. Very good question. That question I'm waiting from you. Okay, okay, look at here. I just take zero, for example, 0.5. Okay, look at this graph. Okay, this is 0.5, and it said not include, right? Not include 0.5. Okay, and the arrow is to the left. Okay, what is the value to the left? 0.5. So this value on the left is 0.49, 0.499, 0.4999, 0.49999999999999999999. Okay, okay, but the value is not include, is only 0.5. The rest is include. Is it clear? The only value not include is 0.5. The only value not include is 0.5. That's why when you this, you need to move a little bit to the left. Minus 1 over 2n, this will become any value to the left. So the only value not include is only 0.5. The rest is include. That's why this is less than or equal. Okay. The same example, the same explanation for this one, for Najib. This is 0.3. Okay, for example, the same explanation for this. This is 0.3. Okay, the value is not include 0.3, not include 0.3. There is 0.6. But other than that, is include. The only value not include is 0.3. So what is the value include? 0.31. What else? 0.311. 0.3111. Why is very small? Because it's continuous. This line 0.3 to 0.6, there is a lot of value. 0.31, 0.300001 is also included. 0.30000000000001 is also included. But the only value not included is 0.3. Is it, Najib? You can understand why? So after CCF, the symbol will be less than or equal or more than or equal, because the new value will be included. Yes, yes, yes. But, okay, but after you do a CCF, if you forget, okay, let's say you forget to put this one, let's say you just follow the original symbol. It doesn't matter, actually. Doesn't matter. It will not give you the wrong answer. So don't worry. Okay, don't worry. But me as a lecturer, I need to explain the right thing. So this should be include. But if you forget to put this include, just follow this less than, doesn't matter. Your final answer will be similar with the correct answer. Okay. But something you need to stress out is the first one. Is it include or not? Oh, include zero. It's not include 0.3. So how to make a decision of CCF, either plus or minus? That is the first CCF is very important. But after that, we just need to transform into Z. So it's already in Z. We just take the value. Okay, the equality symbol will not affect the value. Okay, so it doesn't matter either you put less than or equal or forget it. Okay, okay, but it's good for you to uh, write the right symbol here. Okay, okay, any question about the CCF? About the CCF? No. Okay, so now let's say we want to, okay, okay, so we know P is follow normal distribution with pi, mean pi, and the variant pi 1 minus pi over n. So now we know we can transform any variable that follow normal distribution into Z transformation. So in this case, what is the formula? Remember this, the general formula. So you just need to substitute into this general form. This is P. Remember, Z equal to random variable minus the mean for random variable. In this case, the mean of your random variable is pi, and the square root of the variant of your random variable. So in this case, pi 1 minus pi over n. Okay, so this is the Z transformation. Okay, so this is the Z transformation is you need to do after you do a CCF. Okay, so we look at another, we try to look at the example. Okay, look at this question. Okay, so this is a question, I don't know, in your books. This is the task in your books. You can refer to your books. Okay, this question task, I don't know, task 5. Is it task 5? Task 5, yeah. Okay, 2.5. Okay, task 2.5. Okay, anyone? Page is a page 49. Thank you, women. Oh, okay. So if anybody still don't get the book, so you need to copy this. You need to write down this question. 30% of pipe in the chemical plant showed a sign of serious corrosion. A survey was done and a random sample of 100 pipes in the chemical plant was selected. Find the probability that more than 35 pipes in the chemical plant showed signs of serious corrosion. From 20% to 30% of pipes in the chemical plant showed sign of serious corrosion. Okay, now if you look at this question, it's look like binomial. Okay, it's look like a binomial. How do we know it's a binomial process? Okay, how do we know? This question can be binomial question and can be negative binomial question. Okay, how do we know this is? Maybe we can solve by using binomial. How do we know? Okay, when you take yes, two outcome only. Yes, good, very good, Najib. Okay, we have only two possible outcomes of the condition of the pipes, either still okay or have already have a serious corrosion. So that is only two possible outcomes. So that is the original is a binomial. So now we take a sample. We take a sample 100. This is the problem. Why we cannot solve by using a binomial? Because n equal to 100 is not provided in your table for binomial distribution. Okay, 100. Okay, 100 pipes. If you want to use a binomial, I will show you. If you want to solve by using binomial, I will show you after this. Okay, so 35%, 30% of pipes. What is the symbol for this? What is the suitable symbol for 30%? Oh, this is 0.3. What is the suitable symbol for this 0.3? Pi, yes. Good, good, Nurul. Good, Chan. Okay, this is actually pi. Okay, okay, that is pi. Okay, that is pi. Why pi? Because that information refer to all to all pipes in the chemical plant. Okay, it's refer to the rate for all pipes in that chemical plant. Okay, how many pipes that we have in that chemical plant? How many? The total pipes in that chemical plant, how many? Lots, we don't know. Okay, is it 100? 100 is just a sample. Muiz, more than 100. Yes, good, more than 100. Okay, more than 100. That's why we just give you the general pi. Okay, that 100 pipes is a sample. Muiz, it's a sample. Okay, so now we take a sample n equal to 100. Okay, take a sample n equal to 100. Okay, find the probability that more than 35 pipes, 35% pipes, more than 35%. Okay, more than 35. Okay, for the first question. Okay, maybe this is the clue that we can get the idea. Either we can solve by using a proportion or not. Okay, if we ask you if the question in form of percentage, okay, maybe you can solve by using proportion. Okay, that is the clue, that is the tips actually. Okay, if the question asks you more than 35% of the pipes, 20% to 30% is in percentage. Okay, so that is the idea. Oh, maybe we can solve by using proportion. Okay, so that is the idea. Okay, so in this case 35%, find the probability that 35% more than sample proportion from 100, from that 100 pipes of sample, more than 0.35. Don't forget to change from percentage to decimal value. Okay, write down in your notes. Don't forget to change 35% to decimal value. Okay. Okay. So first you need to do a CCF. Okay, now do the CCF. Is it plus or minus? Equal. Para equal. Is it plus or minus? It's plus. Okay, good. Plus. Okay, you can draw, you can make a decision by drawing. This is 0.35. It's not include, the arrow is to the right. So in this case, we need to move a little bit to the right. Okay, so since we need to move a little bit to the right, it's plus. Okay, okay, so now this is, we already solve this one. The probability of the proportion greater than or equal, this is 0.355. Okay, so after you already do the CCF, then you can transform into Z. Okay, so we transform into Z, P transform into Z greater than or equal. Okay, now look at the distribution for P. This is 0.3, 0.3 times 0.7 over 100. Okay, so that is the distribution for P. Okay, the formula, that formula is given. Okay, the distribution for P, the Z transformation for P, that formula are given in the list of formulas, so don't worry, just need to refer. Okay, so this is 0.355 minus 0.3 over square root. Okay, let's say you already calculate this into the single value. 0.3 times 0.7 over 100. Can anyone give me the single value here? 0.0021. Thank you, Kong. Thank you, Nurul. Thank you, Farah. Thank you, Najib. Thank you. Thank you very much. Okay, so you don't have to calculate, you don't have to write 0.3 times 0.7 over and over. Just square root 0.0021. So it's easy for you. We try to make it simple. Okay, but still we show all the procedure. Okay, so now this is Z greater than or equal, this is a positive value. So since that is positive value, if we draw the curve, okay, this is 0, the value 1.2 and Najib, this is 1.2. Okay, thank you. So this is 1.2. The error is on the right, so directly you can find from the table. Okay, what is the answer? 0.1151. Okay, thank you, Nurul. Thank you, Kong. Okay, Farah, what is that answer? 0.0? Ah, tak ada. Apa tu tak ada? Najib, apa yang tak ada? Oh, tak, apa yang tak. Oh, emoji. Tak keluar emoji lah kat sini. Kat laptop tak keluar emoji lah. Okay, 0.1151. Okay, so any question? Okay, so that is, if you want to, let's say you think, since we have only two possible outcomes, we have a serious correlation or we don't have a serious correlation. Okay, so you think you can solve by using a binomial. So let's say you want to solve by a binomial. Okay, let's say you write the binomial, follow the binomial with 100 and this is 0.3. Okay, let's say that is a binomial. So now, since the question more than 35%, when we convert to the value, the item, that is x greater than 35. Okay, so this is if you want to calculate. Okay, when you look, oh, there is no n equal to 100 in the table, so you make a decision, you want to calculate manually. So this is the probability x equal to 36 plus the probability of x equal to 37 plus until the last one is probability x equal to 100. That is how we want to calculate by using binomial. Use the formula. Guna formula pula NCX bla 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 untuk setiap satu ni. Kalau buat macam ni tak grade kamu nanti. Buat benda ni je. Untuk yang bijak sikit, kononnya bijak lah. Oh, bijak sikit. 1 minus probability of x less than or equal to 35. Okay, yang ni konon bijak sikit lah. The probability x equal to 35 plus the probability of x equal to 34 plus until the last one probability of x equal to 0. Sama je. So it's not suitable to solve by using the binomial. Is it clear? So we need to solve by using the proportion. Okay, the second one, the second question. From 20% to 30%. From 20% to 30%. Find the probability, the sample proportion 0.2. This is 0.3. Okay, from. Apa simbol from? From 0.2 to 0.3. Apa simbol dia? What is the symbol? At the beginning, you must use the correct symbol at the beginning because that will affect your CCF. So must correct this symbol. Okay, what is the symbol? If from, is it include 0.2 and 0.3? Okay, good. Yes, it's include. The one that not include is between. Okay. Kalau between, if between, there is not include 0.2 and 0.3. Okay, now do the CCF. Okay, this is 0.2. 1 over 200. Is it plus or minus? This is P. 0.3. Is it plus or minus 1 over 200? You are the one who make a decision. I don't want to give you the answer. If you can understand, then you will give the right symbol, the right procedure. Is it plus or minus? Okay. Okay. Solve until the end. If you already find the answer, get the idea. Okay. Visualize the situation. This is 0.2. This is 0.3. This is include 0.2 until include 0.3. Okay, for 0.2, you need to move a little bit to the right, to the left, or to the right. This one to the left or to the right. There is two options. Okay, for 0.2, is it plus or minus? Minus. Good. Okay, for 0.3. Okay, very good. Very good. Then that means you can understand how to make a decision. Either you need to move a little bit to the left or to the right. Very good. Okay, so since you already know how to make a decision, I think the rest you can solve it. Okay, so this is the equal, change, so this is 0.195, this is P, 0.305. I think the rest you can solve it. Probability of 0.195 minus 0.3 over the square root of 0.0021. This is P. This is 0.305 minus 0.3 over square root 0.0021. Okay, so this is 0. Probability of this is minus value. Oh, sorry. This is not P. Okay. Since we already transform into Z, use the formula, that's become Z. Okay, this is Z. This is a positive value, negative value, positive value. So the area is between here. So if you want to use the value from your table, statistical table, the total area that is equal to 1 minus the area of the right tail minus the area of the left tail. Finally, you will get the answer. Okay, anyone get the answer? What is the answer? Nurul Bagus 0.5328. Anyone get the different answer or same answer with Nurul? Okay, most of you get the same answer. Nabil, Nadia get the same answer. So any question? Any question? Nope. Any question? I think it's easy, right? Senang kan? Ada soalan? Tak ada? Alhamdulillah. Ada? Tak ada So kalau tak ada kita, so if there is no question, we move to the last part of second chapter. Sampling for P1 minus P2. Okay. Sampling for P1 minus P2. Sampling for P1 minus P2. Okay, so let's say the distribution for P1, let's say the distribution for P1, this is follow normal with pi 1, 1 minus pi 1 over n1. And the distribution for P2, this is follow normal with pi 2, 1 minus pi 2 over n2. So the distribution for difference between P1 minus P2 will also follow normal distribution. Look at the order. This is 1 minus 2. Okay, P1 minus P2. This first item minus second item. So this will be pi 1 minus pi 2. The mean is pi 1 minus pi 2. But the variant, remember the variant always plus. So pi 1, 1 minus pi 1 over n1 plus pi 2, 1 minus pi 2 over n2. Okay, so that is the distribution for P1 minus P2. All these formula are given. Okay, so Z transformation, this is, remember, I give you the general form of the Z transformation, the random variable minus the mean of the random variable over the square root of your random variable. So this will be P1 minus P2 minus pi 1 minus pi 2 over pi 1, 1 minus pi 1 over n1 plus pi 2, 1 minus pi 2 over n2. Okay, so this is the Z transformation. Okay, any question? Okay, it's easy, yeah? It's easy. Okay, so I want to remind you, maybe you can write some remark in your notes. Okay, no need to do CCF for P1 minus P2. Okay, no need to do CCF for P1 minus P2. CCF only for single sample proportion. Okay, is it clear? No need to do a CCF. Any question? Nope. Hello, hello. Soalan tak? Tadi. Okay. No question. Okay. Okay. If there is no question, maybe we can look at the example. Okay, look at the example. Task 2.8 page. Anyone knows what page? Task 2.8. 53. Thank you, Kong. Thank you, Nurul. Thank you, Aina. Okay, 53. Okay, look at page 53. Task 2.8. Okay. A production manager claims that his two machines will fail due to continuous operation and will produce defective product. An investigation was done and it was found that the claim was true. 50 out of 500 products from machine A and 45 out of 500 products from machine B are defective. 100 products from each machine are selected randomly. Okay, now we know that 500, that is a total item from machine A and machine B. Okay, so 500 that refer to the population, because from that 500 we take 100 product for each machine, so that 100 will become your size of the sample. Okay, this is how we solve. You need to know how to write down all the information from the problem. Okay, okay, so now maybe we can write some of the information. Okay, 500, 50 out of 500, 50 over 500. What is the suitable symbol for this one? And 45 over 500. What is the suitable symbol for this one? 50 over 500. The symbol pi A. So this is pi A. Good. This is pi B. Okay, good. Okay, so this is 0.1. This is, anyone knows 45 over 500? What is the value? 0.45. 45 over 500, not 45 over 100. 0. How many? 0. 0.09. Be careful, be careful, be careful. Use your calculator. Okay, use your calculator to confirm the value. 0.09. Okay, now that is pi A and pi B. Okay, now we take a sample, and A equal to 100 and NB is also equal to 100. Okay, okay. 100 product selected randomly. Suppose PA and PB are sampling proportion of defective product produced by machine A and machine B respectively. Find the first one. The probability that PA is smaller than PB. The probability of PA smaller than PB. Okay, in this case, is it, which one do you think we want is more suitable? PA minus PB less than 0, or you want to choose PB minus PA greater than 0. Both of them are correct. But which one do you think is more suitable for this question? Which one do you think more suitable? A minus B or B minus A? Why Najib? Why Taufik? Why Aina? Why Chan? PA minus PB. Why? Why do you think is more suitable? Because Muiz want to use PB minus PA. So in this case, why PA minus PB more suitable than PB minus PA? Why? Why PA minus PB? Why PA minus PB more suitable to write the distribution? Why? Any idea? Why? Anybody want to try? Why? Value of pi? Kenapa dengan value of pi? Dapat positif kalau tolak. Farah. Boleh juga kalau katalah PA lebih kecil daripada pun dalam kes ni PA lebih sesuai. PA tolak PB lagi sesuai. Why? Because the rest two question is PA minus PB. Okay, because the rest all the question refer to PA minus PB. So it's better for us just write PA minus PB only once. So if the first question you choose PB minus PA, then if you want to solve question 2 and question 3, you need to write another distribution. Okay, so we just need to write only one distribution. So in this case, PA minus PB is more suitable lah. So PA minus PB, pi A minus pi B. So 0.1 minus 0.09, that is 0.01. Okay. The variant, anybody can help me? What is the variant for PA minus PB? Anybody can help me? Give me up to 4 significant figure. Anyone can help me? 0.1 times 0.9 over 100 plus 0.09 times 0.91 over 100. Only kalau tiada second dan third question, how we know is if there is no second and third question, you can write PA minus PB or you can choose PB minus PA. Cool. You will get anyone. You can use anyone, PA minus PB or PB minus PA. Doesn't matter. Just in this case, because we have second and third question. So if you want to ada 4 puluhan, bukan 4 puluhan, 4 angka bererti, 4 significant figure. Najib, Farah. Okay, thank you Farah. 0.001719. Okay. In this case, you need to give up to 4 significant figure. 4 angka bererti. Bagilah dalam puluhan Jib. 10 kuasa negatif 3 Jib. Okay. Okay. Thank you. Thank you Farah. Thank you Najib. Thank you Nurul. Okay. So that is the variant. So in this case is more suitable PA minus PB. If you want to choose PB minus PA, then you need to write PB minus PA, another distribution, which is 0 minus 0.01, 0.001719. You need to write 2 distribution. Cool. V min ko. Okay. So ada dua distribution kat situ. Okay. Jadi biar kita guna satu untuk ke semua soalan. Senang untuk kita lah. Okay. Any question before we proceed? Tak ada. So in this case kita tak guna yang ni lah. Kita tak guna yang ni. Walaupun boleh guna yang tu. Tapi kita guna yang sama. PA minus PB. Okay. So the probability of PA. Okay, ni tak buat lah yang ni. Kita tak ambil yang tu. PA minus PB less than 0. So kita tak perlu, we don't have to do a CCF. You can transform directly Z. So this is Z less than 0 minus 0.01 over the square root of 0.001719. Okay, so this is the probability of Z less than minus value. This is 0, this is minus, less than, this is the area. So you can directly find the answer from the table. Okay, fill in the blank. What is the answer? 0.4052. Okay, thank you, Nurul Awada. Anyone get the different answer or same answer? Same? You need to try, all of you need to try. Muhammad Hanif get the same answer. Eva Clay get the same answer. Farah Ilya also get the same answer. Okay. Any question for the first one? Any question before I proceed? Ada soalan? Tak ada? Ada Okay. Kalau tak ada, if there is no question, I add 1A. 1A. I add another question. Let's say the question is like this. Find the probability that PA is better than PB. Fine, no, fine. Okay. Find the probability that PA is better than PB. Find the probability PA is better than PB. What is the correct symbol there? Apa simbol kat situ? What is the correct symbol? PA is better than PB. Less than. Kong said less than. Najmi said less than. Chan said less than. What about the rest? Eva Clay said less than. Nabil also less than. We mean co greater than. Chikimi less than. What about the rest? Don't know. Less than. Nuruddin less than. Zonon also less than. What about the rest? Yang lain? Yang lain tak tahu? Less than, better. In this case, better. You need to look at what is the nature of your measurement. Okay. PA. PA represent the defective proportion. Okay. So in this case, better means less defect. Okay. That means this the right symbol is less than. Okay. Okay. We Mingko. Okay. In this case, it's less than. You need to look at the nature of your value. Okay. Is it the bigger value represent the better things, or the smaller value represent the better things? Okay, because in this case, this is better than, better in terms of quality. So you need to investigate. Either better means greater, or better means not greater or less than. Okay, so be careful. Okay, so in this case, better is less than. So you same with the previous question. Okay, any question you can ask me anytime. Okay, look at the second one. The probability that the modulus PA minus PB is less than 1.8%. Okay, second question. The second question, the probability of modulus PA minus PB is less than 1.8%. 1.8%. Is it correct? Is it correct? Apa yang silap? Okay. Banyak betul kau punya kosong, Nurul. Jadi tekan calculator Tekan calculator terlebih pula 0.018. Okay. I just want to show, be careful when you look at the value 1.8%. Use your calculator. 1.8 over 100. What is the value? Okay. So this is 0.018. Okay. So now don't have to do a CCF. But in this case, we have a modulus. Okay, we have a modulus. So be careful. Okay, when we have a modulus, we need to open the modulus first. Okay, we need to open the modulus first. So for modulus, I give you the simple example. Let's say modulus x greater than or equal, less than or equal to 5, for example. So what is the value of x that fulfill this condition? What is the range of x that's satisfy this condition? Okay, very good, Najib. So this is minus 5 less than or equal to x less than or equal to 5. Okay, so if we want to find the probability of modulus x less than 5, so that is actually the probability of x less than minus 5, less than 5. Okay, modulus less than 5 this is the, we need to open the modulus. So when we open the modulus, this is the range of x. Okay, doesn't matter. So if this is less than or equal, so it's include less than or equal, less than or equal. But for less than only, this is less than, less than. But what about more than? The modulus of x greater than 5. X X greater than 5. Apa tu Najib? Kau main pusing ke? Okay, union with X less than or equal to minus 5. Dia tak bersambung. Dia tak bersambung. Kalau kita, if we draw the line graph, this is minus 5, this is 5. For this case is the dia tak bersentuh. Dia dua area yang berbeza, jauh-jauh tu. Boleh Najib Okay. Okay, so in this case, if we want to find the probability for modulus x greater than 5, so that is actually we need to separate the value. The probability for x less than minus 5 plus the probability of x greater than 5. Okay, that is if the modulus greater than. Okay. Okay, so you can calculate this one. This is actually the probability of minus 0.018. This is PA minus PB. This is 0.018. Okay, so solve this one. Okay, so this one. Okay, probability equal to minus 0.018 minus 0.01 over the square root 0.001719. Itulah. Okay, ni Z. Ni Z. Ni 0.018 minus 0.01 over square root of 0.001719. Okay, so selesaikan, solve this one. The probability of this is minus value, this is positive value. If we draw, this is 0, this is minus, this is positive. The area is between these two. So this is 1 minus the value of the right tail and the left tail. Okay. Apa jawapan dia? Anyone can give me the answer? 0.3270. Okay, what about the rest? Okay, Kong and Najib get the same answer. Very good. Okay, so that is the correct answer. Congratulations. Any question? Any question? Nope. Nope. Ada soalan tak? Tak ada. Okay. If you get the answer as given answer, I don't know. The given answer is 0.673. dalam buku, in your books? Is it 0.6730? That is the wrong answer. That is the wrong answer. That is the answer for greater than, not less than. Okay. So if you get 0.327, that is the right answer, the correct answer. Okay. Okay. So now I want to give you the idea when we need to use the modulus. Okay, when we need to use modulus. Okay, listen carefully. Okay, when we need to use modulus, when we want to find the difference between the proportion, but we don't know the order. For example, this question B. Okay, question number 2 can become like this. Find the probability the difference between these two sample proportion is less than 1.8%. Okay, let's say this is the question. This question, the probability that the difference between these two sample proportion is less than 1.8%. Is it PA minus PB or PB minus PA? Is it PA minus PB or PB minus PA? If this is the question. Hello? Hello? PA minus PB or PB minus PA? Both? So, in the question, we not give you the order, right? This question, we not give you the order. So, since we not give you the order, then you need to use a modulus. PA minus PB. You need to use modulus. Or, you can use modulus PB minus PA. You will get the same answer. Okay? Is it clear? When we need to use modulus, when the order is not clear, is it A minus B or B minus A? 1 minus 2 or 2 minus 1? Okay? It's general. The difference between these two proportion, sample proportion. Okay? It's not clear. In this case, we not give you the order, so you need to use modulus. But if we give you the probability, find the probability, the difference between PA and PB, and then PA minus PB without modulus. Or we ask you find the probability, the difference between PB and PA, we give you the order, PB minus PA, then you don't have to use modulus. But if we give you the general like this, between these two sample proportion, without give you the order, then you need to put modulus. Is it clear? Okay. Okay. Either clear or not, you need to write in your notes. Okay. You need to write in your notes. Okay. That is very important. Okay. If there is no question, the last one, I think you know how to calculate that one. Find the probability that PA minus PB is at least 1%. The last one, the third one, Find the probability PA minus PB is at least 1%. So what is the answer? Okay, so this is Z greater than or equal 0.1 minus, sorry, 0.1 minus 0.01 over square root 0.001719. So this is the probability of Z greater than or equal to 0. So this is equal to 0.5. Okay, good. Very good. Because it's represent the area on the right. This is 0.5. Okay. Any question? Any question? No. Okay, so that is the end of chapter 2. So next week we will move to the chapter 3, third chapter. So for chapter 3 and onwards, I already have the videos and the link. You need to refer to the e-learning. I already shared the link for my video for chapter 3 until chapter 7. So you can look at that video first. It's very short video. Test 1 until here, right? Yes, until chapter 2. Test 1 until chapter 2. Chapter 1 and chapter 2. Yes. Any question? I also share the supplementary exercise of chapter 2 in the e-learning. Date for test 1, 26th of November. 26th of November. I will give you the complete information about the test 1 in our WhatsApp group. I will share the information. Chi-square and T-distribution not covered in chapter 2? Yes, not covered. At the end of chapter 2, there is some several distribution. T-distribution, chi-square distribution, and F distribution. That is the introduction, the distribution that we will use in chapter 3 and onwards. How we will conduct our test, face to face on the camera. So I know you not look at the books on the camera. So I can monitor all of you. Okay. Any question? Any other question? Test at night. Since morning I have class. Yes. 8 o'clock. 8 o'clock. No, no, no. What do you mean no, no, Najib? Oh, no question. Kenakan aku balik Okay. Okay. Any question? No? Okay, so since there is no question, so we can stop our class now. With that, Assalamualaikum warahmatullahi wabarakatuh.